Trichotomy is just the idea that there are numbers that are big, small, and the same. Does that make sense? And we recognize it as an inequality, like x is greater than 3. That's trichotomy. Okay, big name. It's just inequality. But we assume one thing here. When we see this, we assume the domain is all reals. Right? We talked about this the other day a little bit, right? We assume that 4.2 is okay. All right? 4.9, 5.327, 7 times the square root of 2. Right? Anything greater than 3 for a decimal value would work. And we would graph this simply like this. And it indicates that this can be any value greater than 3. 3.102, 7 times square root of 2, anything that decimally is greater than 3. But when we do these problems, sometimes we're defined to certain things. And I use the bus example, right? If I'm a bus company, I can't deliver 3.1 buses. So in this case, it would actually be positive integers, but I'll just call it integers. And I decide that my bus company will not ship a bus to a new customer unless they want more than 3. It's just not worth my time to do it. What that means is, from a graphical standpoint, and once you see that you have a domain that's not real, you're going to have to tick mark more than I make that. You're going to have to number line out. Well, we think to ourselves, x is greater than 3, so hopefully by now we're all good enough to picture this in our heads. And the reason I got the green is we can't draw that. It can't be all values greater than 3. It can only be the integers. Well, what's the integers greater than 3? 4, 5, 6, 7, 8. And we just got the values. And if we do not put this 6 here, right now this is just 4 and 5. If I leave the 6 up there. If I take the 6 off again, right now it's 4, 5. And since the arrow's here, we assume the sequence continues. So it's every number thereafter. The hard part here, if I just do one more example, is when we have categories like this. All right. So it says negative x minus 4 is not greater than or equal to negative 2. If it's not greater or equal, it has to be less. So the first thing I do is get rid of the negated inequality. We know that there's only 3 things it can be. It's either greater, less, or equal. If you cross out 2 of them, it has to be the other. I'll solve for that, and I'll get negative x is less than 2. This is where you got to remember. When you have a negative number and you multiply or divide, the inequality has to switch. All right, so if I do this, I get x is greater than negative 2. Now let's take 1 second. We'll come back to this point. Let's take 1 second. Remember, the reason it reflects, all right, is that when you're on a number line and you think to yourself, I want to go to 2. When you multiply by a negative, all it does is mirror that line. So the reason you have to switch the inequality, does everybody agree that 3 is greater than 2? Because 3 is further to the right than 2? But remember, when you multiply by a negative, it simply reflects the values. And thus, negative 3 is further away from 0 than negative 2. But what's greater, negative 2 or negative 3? Negative 2 is greater because it's further to the right. When you multiply or divide an inequality by a negative number, it switches to side. All right. But back to this. We solve for x. X is greater than negative 2. In our heads, we don't want to, hopefully you're thinking about this again. You picture it this way, x is greater than negative 2. But you can't do this because the domain's not real. It's negative integers. So I put on a bunch of numbers all around this. What you're picturing the blue, but what is the negative integers greater than negative 2? Just negative 1. And this whole graph this time, and I'll move that off, is just that point. This is hard, and sometimes I have students actually, you might want to start by actually dotting in what it is. Then you have to say to yourself, how does the domain affect this? Let's take practice. We'll work again on this on Monday.